In this video, we'll discuss chain rule. So that's a new way to calculate, to find the duality of some given function, right? So let's see when do we apply chain rule, right? What kind of function we can apply chain rule? So we can, given two new functions, two differentiable functions. So f g here are differentiable. So that's our assumption. Differentiable. I suppose that. And suppose you can map G maps every x to the domain of f, right? Then you get a new function, which is the composition of G and f, right? So you're starting x, starting from input, right? X, you apply G, function G, you get G of x. Then you apply function f on this new function, on this new number here, you get f of G of x. So this function here has a name. This is a composition of f and g, which is f circle g, right? F circle g of x is f of g of x. Now the question here is this new function differentiable? If this new function is differentiable, what is the duality, right? So let's try to do that. So before we let's write down, right? Suppose write down our assumptions. Suppose f and g here are differentiable, right? Chain rule here deal with the composition of two functions. This is called the composition of f and g, right? And so we gave a new name for this new function, which is called a capital F of x is f circle g of x. The definition for that is f of g of x, right? We want to differentiate this function. We want to know whether this duality whether the duality exists. Right? This is same as f circle g of x prime. So this is same as f of g of x prime. Now we want to know what is this? What's the formula for that, right? Let's try to derive it using our definition of duality. Remember that we don't have any other ways, right? We don't have any way to evaluate the duality of the composition of two functions. And so we can only starting from our definition, right? So what? So f prime of x by our definition is same as h goes to 0. What's that? Capital F of x plus h minus f of x over h. That's our definition, always, right? If you don't have any other tricks, go back to that definition, right? Plug in the function definition. So this is same as h goes to 0. F of g of x plus h minus f of g of x over h, right? Now, how do we do this, right? And so, okay, now you can see that, because g is differentiable, which means g is continuous. So this input actually getting closer and closer to that as h goes 0, right? So, so if you want to use our definition for the derivative, so the denominator should be g of x plus h minus g of x, right? To use the derivative of f, right? So this is same as h goes to 0, f of g of x plus h minus f of g of x You can consider g of x as a here, right? Then g of x plus h is some term getting closer and closer to a. And we want to keep the same number, right? Or as I said, it's kind of dummy variable, right? Anything doesn't cause contradiction should work, right? So this is g of x plus h minus g of x over h. So I don't change the function form. I put a number, put a term in between, right? And so this term getting closer and closer to that, the denominator is a difference. So the first factor, because f is differentiable, the first factor is basically the derivative of whatever number that is. The second term is the standard definition for g prime of x as h goes 0, right? So that is the derivative of the composition of this function. So you get this is f prime of g of x times g prime of x. So this is our chain rule, right? This is how do we find the derivative of the composition of two differentiable functions. If you have two differentiable functions, their composition is also differentiable. The derivative is the derivative of the first function, plug into the second function, then times the derivative of the second function. Okay, let's see a couple examples. Our function is f of x equal to sine of x squared, right? So you want to decompose your function as two functions and such that you know how to differentiate each of them. Then you apply chain rule, right? So in this function, we know that the inner function g of x is basically x squared. The outer function f of x is basically sine of x, right? So f of g of x will be sine of x squared, right? So we know that this is f prime. We need to know the derivative. This is cosine of x, and g prime of x is 2x, right? So f prime of x should be f prime of g of x times g prime of x, right? So f prime is cosine. Cosine of g of x is x squared, have x squared here. Then times g prime is 2x. So this is how do we differentiate this function, right? This is our first example. Apply chain rule, right? So this is chain rule directly. Now let's see one more example. B here, our function f of x is square root 1 plus 2x cubed, right? In this case, our inner function g of x is 1 plus 2x cubed. So g prime of x is 6x squared, right? Then f of x is root x. So f prime of x is 1/2 x to negative 1/2, right? So capital F of x prime applied chain rule should be the derivative of the outer function, then keep inner function, then time g prime of x, right? So plugging all we have, this is 1/2 inner function is 1 plus 2x cubed to the power negative 1/2 times g prime, which is 6x squared. So this is how do we apply chain rule to evaluate the derivative of some composition of functions.